Hello guys, I'm Cheriyan. Today we are going to do little more problems from maxima, minima and turning points. Okay, let us do. Find the turning points. Find the turning point or critical point. Find the turning points or critical points. And maximum value or minimum value or maxima or minima. And maxima and minima, or local maxima or local minima. And one more thing, where the function is increasing, where the function is increasing or decreasing. Question number A, increasing, B, decreasing. Okay, those are the questions. Okay, first one, first function, y equals or fx equals x cube minus 12x plus 1. Okay, this is the question. So we can find out fx is equal to x cube minus 12x plus 1. What are the formulas? At the turning point, these are the formulas. I am going to write the formulas here. Okay, at the turning point, what is that? Or critical point, f dash x is equal to 0. How can you find out the maxima minima? At the maximum point, what is that? f2 dash x, second derivative, is negative, less than 0. At the minimum point, f2 dash x is greater than 0, positive. Minimum point positive, maximum point negative. Okay, first f dash x equals, what is the derivative of x cube? 3x square minus, what is the derivative of 12x? 12, right? So take out 3 common factor, x square minus 4 equals 0. So this is equal to 0. Dividing throughout by 3, so you get x square minus 4 equals 0. X is equal to what? X square equals 4. X is equal to plus or minus 2. So you get 2 points. One point x coordinate, okay? One is plus 2 and the other one is negative 2. Maybe the graph is like this or the graph is like this. We don't know. We need to find out. Okay? When x is equal to 2, find y. So you get the points. Okay? Maybe sometimes the point is here, sometimes the point is here, or sometimes the point is here, sometimes. So you need to find the exact point. When x is equal to 2, y is equal to what? Y is equal to 2 cube minus 12 into 2 plus 1. 2 cube is what? 8. 8 minus 24 plus 1. 8 plus 1, 9. 9 minus 24 is 15. Minus 15. So what is that? 2 minus 15. Where is 2 minus 15? 2 minus 15 is somewhere here. 2 minus 15. Okay. Next, minus 2. When x is equal to minus 2, y equals minus 2 cube minus 12 into minus 2 plus 1. So minus 2 cube is minus 8. Minus into minus plus 24 plus 1. 24 plus 1 is 25. 25 minus 8 is 17, right? 17, right? 17 70. 2 minus 2, 70. Minus 2, 17 is somewhere here. Minus 2, 17. So the graph is like, okay, I will find this when x cube. Okay, x cube minus 12x. Okay, maybe the graph is like okay, like that. So what is the next question? Oh, which one is the maximum point? Okay, turning points we've already found. That is minus 270. The first answer is minus 217 and 215, 2 negative 15. So from the graph it is clear this is the maximum point, this is the minimum point, but we need to find out. We need to find out theoretically. How can you find out? Second derivative, find out the second derivative. First derivative is this, second derivative is that f2 dash x. See, f2 dash x is negative, then that point is maximum. See, f2 dash x is what? F2 dash x is, f dash x is this, 3x square, 3 into derivative of x square is, I will write the first derivative here, 3x square minus 12. Second derivative, 3 into 2, 6x. What is the derivative of minus 12? 0. So 6 into, what is the first point? Put minus 2 here. X is equal to minus 2. So minus 2. 6. Just put the value here. What is that? 6 times minus 2 is minus 12. You don't need that number. You only need negative or positive. This one is negative. See, the second derivative is negative, then maximum point. This is the maximum point. Therefore, minus 217 is the maximum point. Okay, maximum point. What is maximum? Maximum means maximum value is 70. Is 70. That is the maximum value of the function. It means x cube minus 12x plus 1. This is the function. You put whatever, you can enter any value for x, but when you put x is equal to minus 2, 17 is the maximum value. That is the question in this range. Okay? Okay, minus 2, 17. Okay. Next. What is next? Maxima, minima. Okay, minima. Then f2 dash x, you need to find out this is the minimum point. Okay? f2 dash x, again, f2 dash x is equal to what? 6x. So, just put x is equal to 2. So, 12. Positive. Right? So, when x is equal to 2, f2 dash x is positive. So, this is the minimum point. So, 2 minus 15 is the minimum point. Okay? So, we answered 1, 2 and the last one, increasing and decreasing. I am going to erase this one. So, what is the, if it is increasing, if the function is increasing, what is that? F dash x is greater than 0, positive. If the function is decreasing, f dash x is negative. Okay? Those are the things, two things you need to remember. Okay? What is f dash x? F dash x is 3, derivative of x cube, 3x square minus 12. Okay, 3x square minus 12. So, when it is when the function is increasing, 3x square minus 12 greater than 0, right? So what is that? 3 into x square minus 4 is greater than 0. 3 into, you need to factorize. A square minus 4 is a square minus b square is what? A plus b into a minus b. Same thing. X square minus 2 square is what? X plus 2 into x minus 2. Okay? X minus 2 into x plus 2 greater than 0. X is equal to, x is great, when x minus 2 is greater than 0, x is greater than 2. See, when x is greater than 2, the function is increasing, positive. See this, see, just check. When x is 3, y is, when x is 3, okay. Oh, 3, it won't be 3, okay. So x is greater than 2. Let us check, okay, let us check. And then, when x is greater than 2, 3, just put 3. 3 square, 9 times 3. 9 times 3 is 27. 27 minus 12 is positive, correct. When x is 4, okay, that's right. When x is greater than 2, the value of the function is greater than 0. So that is right. Then when x is less than x is less than 2. So x is negative 2, right? X is less than negative 2, greater than negative 2, but we need to put negative 2. When x is negative 2, greater than, less than negative 2, means negative 3. Negative 3 square is again 9. 9 times 3 is 27. Positive. Is correct. So x is greater than 2 and x is less than negative 2. The function is increasing. Positive. See, there are two values. X is greater than 2 and x is less than 2. We can write something like this. Negative 2. X is, the least value of x is negative 2. X is greater than negative 2. No, that is wrong. Yeah, x is greater than 2 and x is less than negative 2. So, for increasing. See here, the function is increasing. Here also, the function is increasing. Yeah, this one is okay. Next. Okay, next, what happened to in between these two values? Negative 2 and negative. See, we can put 0 here. 0 in between. 0 negative. So in between any value, negative 1, that is also negative. So x lies in between 2 and negative 2, the function is decreasing. The function is decreasing. See, when x is minus 1 square, 1. 1 times 3, 3. 3 minus 1, negative. So f dash x is negative when x is minus 2. Minus 1. I just select a 1 integer in between minus 2 and 2. Then 1 is also in between 2 and minus 2. When you put 1 here, the same thing, negative. So decreasing, function is decreasing. So in between these values, the function is decreasing. Okay? Okay. Next. This one finished. See, x is greater than 2 and x is less than negative 2, the function is increasing. The value of x lies in between -2 and 2, the function is decreasing. Okay? Next one. Okay, next one. Y is equal to x raised to 4. Y is equal to x raised to 4 minus 4x minus 1. First, y dash is equal to what? First derivative is what? X raised to 4. Derivative of x raised to 4x cube minus 4. So, equal to 0. Find the turning points. X cube minus 1 equals 0. Dividing throughout by 4, you get x cube minus 1 equals 0. X cube is equal to 1. X is equal to 1. Okay? Only one value. The others are, imaginary roots. You don't need that. X is equal to 1. When x is equal to 1, find the value of y. Where x is equal to 1, y is equal to 1 raised to 4 minus 4 minus 1. 4 times 1 is 4 minus 1. 1 minus 4 is minus 3. Minus 3 minus 1 is minus 4. So turning point is 1 minus 4. We need to find only one point. We don't know what this one is, maximum point or minimum point. We need to find out. Find the second derivative. Y2 dash equals, what is the derivative of 4x cube? 12x square. 12x square. Okay, 12x square. When x is equal to 1, what is that? 12 into 1 square, 12. Positive. So this one is a minimum point. Okay, then s cube, the last one. Function is increasing. Where the function is increasing? That is the question. S cube minus 1 greater than 0. X cube is greater than 1. X is greater than 1. Right? So what are the values greater than 1? What are the integers? Just 2. Put 2. 2 cube. 8. 8 times 4. 32. 32 minus 4, right? 32 minus is a positive number. So this one is right. X is greater than 1. Then the function is increasing. The function is increasing. What happened to x less than 1? When x is equal to less than 1, 0. 0 cube is 0. 0 times 4 is 0. 0 minus 4 is minus. So this is increasing function. This one is decreasing function. When the value is less than 1, the function is decreasing. When the value is greater than 1, the function is increasing. Okay? That is easy. Okay, next one. The last one. Y is equal to x raised to 4 minus 2x square plus 3. Y dash divided by dx equals, what is the derivative of 4? X raised to 4. 4x cube minus 2 into, what is the derivative of x square? 2x. What is the derivative of 3? 0. 4x cube minus 4x equals 0. Turning point. Find out the turning point. Okay, I am going to take 4x as a common factor. When you take out 4x as a common factor, what is the leftover in the first term? X square minus 1. equals 0. See here, x is equal to 0. When 4x is equal to 0, x is equal to 0. First one. When x square minus 1 is equal to 0, x square is equal to 1, x is equal to plus or minus 1. So here you get x is equal to 1 and x is equal to minus 1. There are 3 points we need to find out. Okay. When x is equal to 0, what is the turning point? 0 raised to 4, 0, 3. 0, 3 is one of the turning points. Then when x is equal to 1, what is the other y value? 1 raised to 4, 1, minus 2, plus 3. 1 plus 3, 4. 4 minus 2, 2. 1, 2 is the another one. Then minus 1. When x is equal to minus 1, minus 1 raised to 4, 1. Minus 1 square, minus 2, plus 3. 3 plus 1, 4. 4 minus 2, 2. It's the same thing. See, 1, 2, where are the points? Just 0, 3. 0, 3 is somewhere here. And 1, 2. 1 is here, 2 is somewhere here. Then minus 1, 2. Minus 1, 2. See, these are the turning points. I think turning points is like this. This is the only chance, right? Turning points is like this. Okay, we got the turning points. That is the first problem. First one. Find the turning points. Then maxima, minima. Find what is the maxima, minima. Second derivative, y2 dash. y2 dash is derivative of this one, 4x cube. 4 into, what is the derivative of x cube? 3x square. 4 into 3, 12x square. Minus, what is the derivative of 4x? 4. Okay. Second derivative is negative. Okay. This is the second derivative. Then we need to find out this one is a maximum point or a minimum point. When you substitute 0 here, you get negative. Negative when x is equal to 0. That is, this point is a maximum point. Where is 0, 3? 0, this is a maximum point. Correct. 0, 3 is a maximum point. Then 1, 2. 1, 2. These are equal, right? Let us check. 1, 2. When x is equal to 1. 12 minus 4. 12 minus 4 is 8. Positive. When x is equal to 1, positive. When x is equal to minus 1, positive. So these two are minimum points. 1, 2 and minus 1, 2 are minimum points. Okay? That's right. So 0, 3 is the maximum point. 0, 3 is the maximum point and these are the minimum points. Okay, that's over. Then we need to find the turning points. F dash x, this is f dash x, greater 4x into x square minus 1. 4x into, what is that? X plus 1 into x minus 1. Greater than 0, increasing function. So x is greater than 1. Let us put the value. Here, x is greater than 1. What is, just tell me an example of integer greater than 1. That is 2, right? When you put 2 here, you get unit positive. Correct. When x is greater than 1, when x is greater than 1, this one is minus 1, 2. This one is 1, 2. Okay. Okay. See, when x is greater than 1, increasing. Okay. Next. When x is greater than minus 1. X is greater than minus 1. Let us check. When x is greater than minus 1, what is, there is an example. Can you tell me an example of an integer greater than negative 1? 0. When you put 0, you don't get anything. Okay. When you get 0, when you put 0, is almost 0. So just x is greater than -1. Another example, negative half. X is equal to negative half. When you put negative half, 4 times negative half, so you get a negative number. So when x is greater than -1 and see in between -1 and 1, you get negative number. So x lies in between 1 and -1. The function is decreasing. See, dy by dx is here. Dy by dx is 4x into x square minus 1. So we need, if it's 0, it is not correct. So less than 0 and 0 less than x. What is the greatest value? 1. So this is correct. Decreasing. Okay. So these are the answer. So increasing, decreasing function little difficult. We can do little more problems for the next class. Okay. Thank you for watching this video. Thank you very much.